in example 2, we take a look at another function, somewhat similar. So the function is the square root of x squared plus y squared. So again, we first try to determine the domain. So here, because the function involves a square root, you can't take the square root of a negative number, right? So to understand the domain, we need to have the part that's inside the square root, which is x squared plus y squared. This has to be greater than or equal to 0. However, if we look at this expression here, right, so x squared can never be negative, and y squared can also never be negative, right, because you're squaring it. And so when you add two non-negative numbers, the whole thing is also non-negative. So automatically x squared plus y squared is always greater than or equal to 0 for every real number x and y. So this holds for all x, y. So again, the domain is going to be the all real numbers, the entire xy plane. So we write R2. Okay, so that's the domain. And then part B, we're asked to calculate a function value. Right, so again, -2 is the x value and 5 is the y value. So to calculate it, we just plug it directly into the function. So square root of x, which is -2 squared, plus y, which is 5 squared. So this is 4 plus 25, which is 29. So this is the square root of 29. Okay, and then finally, we sketch the graph of the function. So I've already copied a picture of the GeoGebra output here. One thing to be careful about is that in GeoGebra, the red axis is the x-axis, the green axis is the is the y-axis, and the blue axis is the z-axis. So this diagram is somewhat rotated from the usual orientation that we have, right? So usually we think of the x as going out of the page and the y as going horizontal. So this one is slightly rotated in this direction. Okay, so again, even though the picture is here, let me just go into GeoGebra and enter the new function in so we can see what it looks like. So square root, I type it as sqrt, and then inside the square root, I have x squared, and then here the cursor is in the exponent, so I have to get out of the exponent. So plus y squared, and I make sure the whole thing is inside the square root, and now I hit enter, and you can see that the new graph here is exactly this diagram that I have on the page. So the shape of this graph is called a circular cone. Right, so circular again because if you take horizontal cross sections, they form circles. And technically this is only half a cone because we think of this type of surface in three-dimensional space. So the cone in three-dimensional space actually has two parts. So the upper cone, and then there's also a lower cone. So because this only has the upper part, we call it the upper half circular cone. Okay, so that's example 2, and then now let's take a look at example 3. So square root of 9 minus x squared minus y squared. So again, we have something inside a square root. So if we want to determine the domain, the part that's inside the square root, which is 9 minus x squared minus y squared. This has to be greater than or equal to 0. And then we want to try to understand this inequality in terms of x and y, right? So let's add the x squared and the y squared over to the right hand side. So you get 9 is greater than or equal to x squared plus y squared. And so if you take the expression x squared plus y squared equals 9, so that's just a circle of radius 3, and because this is the inequality less than or equal to, so the circle of radius 3 would be the outer boundary, and this also contains everything inside the circle. So when you have a circle and then also everything inside it, the thing is called a disk. So a disk of radius 3, and it's centered at the origin. Okay, so the set notation is to denote it as all pairs x, y, such that x squared plus y squared is less than or equal to 9. Okay, so that's the domain. And then in part B, again, we calculate the function value. This is the x value, this is the y value. So we just plug it into the function and calculate. Right, so you get 9 minus 1 squared plus negative 2 squared. So what is this? 9 minus 1 is 8. 8 minus 4 is 4. So this is the square root of 4, or 2. Okay, so the function value is 2. And then again, I have the GeoGebra output pasted here, but let's again type it into the calculator here, so we can see it drawn, right? So square root of 9 minus x squared minus y squared, the whole thing inside the square root. I hit enter, and you can see that it draws the graph here. So this is a half sphere, right? So it's the top half of a sphere of radius 3, right? The center is at the origin. So this is the upper part of half of a sphere of radius 3, centered at the origin. So this is what the graph is. If you look carefully at the diagram, the positive x-axis is here, the positive y-axis is here, the positive z-axis is here. So again, this diagram is slightly rotated from the usual orientation. Okay, so that's example 3. So these are all sort of typical types of surfaces you encounter in this course.